Welcome to the session 5 of subject code 18 M5S5. So compressed air in the module 5. Here compressed in this I was talking about the compressors. So here vane compressors. In this class I am going to talk about vane compressors. The figure shows the construction and working principle of vane compressors. As I told, vane compressors are of two types, that is balanced vane compressor and the unbalanced vane compressors. Here this is one type of unbalanced vane compressor. It has a rotary constant or variable flow compressor. It consists of a rotor with radial slots. You can observe the radial slots for the vanes to slide in and out of the slot. The rotor along with the vanes are housed in a cam ring with provision for inlet and outlet valves for entering and exit of the air. The rotor is mounted on a splined driving shaft, that is you can observe spring loaded valve, cam ring, rotor and valves. As the shaft rotates, the rotor along with the vane also rotates. Due to the force acting, that is nothing but centrifugal force acting on the vanes, makes the vanes to move out of the slots and make contact with the cam ring, preventing the leakage of air inside the system. Once the rotor rotates, it receives the air and carried out by the vanes, and it gets compressed and delivered to the pressurized air. Nothing but it converts the low pressure air into a high pressure air. The construction and working principle of vane compressor is similar to that of the vane compressor here, that is balanced vane compressor. The flow can be varied by varying the center position of the cam ring with the axis of rotation, that is it creates certain gap there. That distance is nothing but eccentricity. When the centers of the cam ring and rotor coincides, then there is no compression, that is no eccentricity, and when the maximum large flow takes place, thus the flow can be varied from 0 to maximum, and hence the term variable flow. In single stage vane compressor, it can deliver air up to 3 bar, and 2 stage compressors with intercooler can deliver air up to say 10 bar pressure. The vane compressor of unbalanced vane system, you can observe, it has replacing the circular cam ring by elliptical cam ring. The compressor will be balanced but will be at a constant flow. Liquid ring compressor. This is another type of vane compressor, or in other words we can say it is a modified form of vane compressor. It has an intermediate lobes driven by an external gauge. The compressor uses this type of compressor uses number of vanes rotating inside an eccentric housing containing liquid, say about liquid, either it may be oil or water. As the vanes rotate, the liquid is thrown out of by centrifugal force to form a liquid ring in the shape of the contour of the housing. When the liquid ring acts as a seal which prevents the leakage and reduces the friction. Here the rotational speed may be as high as 300 rpm needed to create the ring, liquid ring. You can observe the thing here, that is liquid ring compression. The construction, it has an outlet port as well as an inlet port. It has 2 outlets and 2 inlets so that it can be balanced. That is the amount of fluid or air entering into the system and delivering it to the atmosphere should be same. That is, to balance the pressure of the fluid, here we are going to use the elliptical type of ring. Here you can observe there is to balance this we are using 2 inlets and 2 outlets. Thereby the amount of air pressure entering into the system and should be goes out through the 2 outlets. As the vane rotates, the liquid is thrown out by the centrifugal force, and as I said, it has the liquid ring acts like a sealer which prevents the leakage and produces the friction. The inlet and outlet valves are placed diagonally, that is, which are opposite to each other. You can observe outlet and outlet is opposite to each other, inlet and inlet ports. So lobe compressor. So lobe compressor, it has instead of vanes in case of vane compressor, and here we are using lobes which has larger in size, and these are one type of positive displacement compressor with a very high flow and low pressure needed. Figure shows the lobe compressor. Next is manufacturing of compressed air. Air is used in pneumatic system must be clean and dry. It should not have any contaminants. It should be free from contaminants, that is traces of oil, water vapor, dirt, dust, etc. Because the presence of a contaminants leads wear and tear of the intricate parts, and also it may be break down the system. Because the atmospheric air contains smoke, dust, moisture, etc., which are harmful to the components of pneumatic system, which has to be which is needed to be treated before it enter into the stored in the receiver. Removal of the harmful elements from the compressed air is called a preparation of compressed air. It can be prepared in 3 stages. One is filtering before the air enters the compressor. Second second stage is cooling and drying after it has been compressed. The third step here is local treatment, that is removing dirt and moisture and mixing it with a small quantity of oil. So there are 3 stages you can observe from the figure. There is a filter. So air has to make the air enter into the filters, thereby remove the debris present in the air, and it will be sent it to the compressor. And once the air gets compressed, it should be cooled to certain extent, because the pressure once the pressure of the air increases, temperature also increases. Okay, it should be cooled. After cooled, it should be dried. There, when it enter into the dryer, the moisture present in the air gets dried off, and then air enter into the dryer. When the moisture content dried off, then it send it to the receiver, where receiver receives the air from the dried air from the dryer and send it to the local treatment, where the small amount of dust can be removed here, and then to the actuator, where it actuates, or the movement of the actuator converts into another form of energy, and then once the energy is taken from the air, and it should be sent it to the atmosphere. Hence the pneumatic system is called as open system compared to hydraulic systems. This hydraulic system is a closed system, whereas pneumatic system is an open system because air will be taken from the atmosphere, and then once the process is done, then it should be sent to the atmosphere. But whereas in the fluid system, that is oil hydraulics or hydraulic system, what will happen? The same oil is used again and again for the purpose. Preparation of compressed air. In the stage 1, as I said, the air before entering the compressor, it is to be free from the dust particles, etc. That is, it should be filtered because it should not damage to the intricate parts of the compressor. Second step is, due to the compression, the air gets heated up. This need to be cooled and dried off to remove the moisture content with the help of a dryer and cooling, as I said earlier. In the stage 3, the pressure air is from the receiver before being used into the actuator is again filtered and dried using filters and dryers, that is in the local treatment. After that, it has to be lubricated, that is, depending on the use, the air is mixed with a small amount of good lubricating oil to assist in lubrication, because due to frictional forces, the rubbing action of the intricate parts, the frictional forces exist, so that has to be removed, and the temperature exists due to the frictional force also to be removed. So for that we have to mix the oil, but this mixing of oil may not be required in most of the applications, but in certain applications it is needed. Okay, that is especially in the mechanical system. When it comes to food and food processing and chemical industries, it may not be used. Mixing of oil stage may not be used. This third stage is also called as secondary treatment of air. Air filters. See, you can observe the air filters. The figure shows the air filter. This is filter and water trap separator. So the primary function of the filter is to filter the filtrates, that is dust, smoke and other entries in the entries with the air, entries along with the air into the compressor. The pneumatic elements and actuators to prevent damage to them. Filters may be dry filters and wet filters. It is of two types, that is, either it is dry filters and wet filters. The dry filters, it will not have any liquid content in it, that is, oil may not be mixed with air here. Maybe in the the food industry and chemical industries, because of there may be a chances of catching fire. So to avoid that, we are going for dry filters. But when it comes to other applications, that is in the mechanical and other applications, we are using wet filters, because the rubbing action, because of its rubbing action, we are using certain lubricating oil. The purpose of the dust, removing dust and dirt particles, the oil also gets attracted, that is liquid droplets, during bubbling and consequently removed by the wire mesh. Next is dryers. So this is one type of chemical dryer. There it consists of a moisture air inlet, condensed liquid, chemical, dry air outlet. So here during compression, the humidity and dew point of air increases. So it has to be bring to the level of humidity and dew point to a reasonable level, that is a functional requirement, based on the functional requirement. The excess moisture has to be removed. That is, in the bulk air system, the air is passed through a simple cooler which helps in condensing the moisture and is drained off. As air enters the inlet of the unit, undergoes a sudden reversal in the direction of flow and swirls with the help of a deflector cone. Both actions of reversal of direction and swirling causes heavier particles to be flung out of the separator wall and gets collected at the bottom. So you can observe from the figure, that is a condensed liquid, and separator wall, and gets collected at the bottom of the unit. Dew point is further lowered with the refrigerator dryer, which chills the air just above 0 degree centigrade, condensing almost all the moisture in the air. Another stage here is refrigerating. That is, refrigerator drying reduces the dew point sufficiently low, which may not be desired in the most processors. That is, when the absolute dry air is required in the then we can go for chemical dryers. That is, chemical dryers can be employed when we need absolutely dry air. So figure shows one such chemical dryer, and also the working principle of the drying the dry air. The chemical agent here absorbs the moisture and slowly forms a liquid which collects at the bottom of the unit. The chemical material needs to be replaced at regular intervals to maintain its efficiency. That is, like in a water filter, like how we are using certain minerals, like that here also we are using chemicals. The unwanted things will be attached or settled there. The chemical dryers are referred to as deliquescent dryers, or also absorption dryers. Lubricators. Figure shows the construction and working principle along with the graphical symbol of lubricators. You can observe here there is a needle valve, inlet, there is a oil mist, check valve, outlet, riser tube, oil bath, glass bowl, central tube. So why we need to go for lubricators is a question here. To the frictional in any mechanical system, pneumatic system, rubbing action between the intricate parts is quite predominant. So in turn the forces exist, which in turn the temperature, of course, it damages the intricate parts. The wear and tear of the parts are quite predominant. To avoid that, it has to be lubricant. So as mentioned earlier, the presence of oil in air is contamination for process controlled pneumatics, which requires clean and dry air. Oil addition is generally carried out during the secondary treatment of air, as it is difficult to store the oil mist laden air in the required state in an air receiver. The function of this lubricator, this is similar to that of a carburetor in an automobile. As the air enters through the inlet, its velocity increases and pressure reduces due to Venturi effect. The difference in pressures at the inlet and outlet after Venturi effect causes oil to rise in the riser tube. Here the oil comes out at the inlet point of air in the form of fine spray and mixes with the air. The function of the needle valve here is to adjust the pressure difference across the oil jet and hence controls the flow of oil. The another device that we are using here is air pressure regulators. Regulators are the devices used to regulate or reduce the pressure. The figure shows one such method of local pressure regulation. It consists of air receiver, pressure regulator. There are two different loads, A and B. There is a Venturi and controller. pressure transducer, control valve. Conventionals are used for both the cases, that is load A and load C. The compressor control system maintains system air pressure within the range whenever there is a drop in the pressure in the receiver within the range. As the compressor may start automatically, and similarly when the pressure in the receiver reaches maximum wall of its range, the compressor may stop automatically. This is due to the help of a pressure switches. A relief valve is also provided. The main function of providing the relief valve is to stand by to protect the compressor in case of pressure once the pressure switches fails.